Okay, hi everybody. We are going to talk about two sections tonight. The first one is section 6.3, proving quadrilaterals are parallelograms. And we're going to try to do these as quickly as possible because it's not really all that tough in the end. Okay? So, let's get right into it with a new theorem. Theorem 8.7, which is also unnamed, says that if both pairs of opposite sides of a quadrilateral are congruent, then the quadrilateral is a parallelogram. Okay? So what that is saying is, that's interesting. Just trying to change the color on my magic pen, and it's not coming up with success, so I'll stop. What that is saying is that if this side and this side are congruent, and if this side and this side are congruent, then you must have a parallelogram. Okay? So let's use our example to look at that. If in quadrilateral ABCD, AB is congruent to DC, and the other sides are also congruent, AD is congruent to BC, okay? Therefore, ABCD is a parallelogram, okay? And that's all there is to it. If you have both opposite sides that are congruent, you must have a parallelogram. Theorem 8.8 says that if both pairs of opposite angles of a quadrilateral are congruent, then the quadrilateral is a parallelogram. Okay? So, much like we just did with the opposite sides, now it's opposite angles. So if we have this one right here and this one right here being congruent, and if we have angle B and angle D that are congruent, then we know we must have a parallelogram. Okay, so let's do our example here real quick. In quadrilateral ABCD, we know that angle A is congruent to angle D. I apologize, that is not correct. We know that angle A is congruent to angle C. So go ahead and make that correction on your paper. And we know that angle B is congruent to angle, not C, but D. Therefore, ABCD is a parallelogram. Okay. Let's see if we can use these. Tell whether PQRS is a parallelogram and explain. Well, we are given 4 side lengths and nothing else, so let's use that. I look for opposite side lengths. There's one right there and one right there. Okay, they are the same. Now let's look at the other sides. Okay. 4 and 4. Those are also the same. So you know by theorem 8.7 that you have a parallelogram. PQRS is quadrilateral where opposite sides are congruent. So PQRS is a parallelogram. Theorem 8.7 tells us so. Okay? Let's try another one. Tell whether PQRS is a parallelogram and explain. Okay? So, we are told that we have a right angle here, a right angle here. Is there any other information we can gather? Well, there is, because well, no, I'm sorry, there is not. We are told absolutely nothing else. Okay, so let's see what we have here. If you see quadrilateral, measure of angle Q and plus measure of angle R is 180 degrees. Okay, so we're so far so good because we did have a theorem last time that said if these two, that says in a parallelogram these two have to be supplementary. So in a parallelogram, you would want angle P plus angle S to equal 180. And of course, that's a measure of each of those. Okay? But we also would need measure of angle P and measure of angle Q to equal 180. And there is no information that tells us that. So we cannot assume, we can't prove that PQRS is a parallelogram. Although the picture, even though it doesn't look like it, it doesn't tell us it's not either. We could later find out that I had my picture that wasn't drawn to scale. Q is really a right angle, R is really a right angle, and that would make it a parallelogram, but we can't say that for certain. So all we can say is that we cannot prove that it is. Okay? Tell whether the quadrilateral is a parallelogram. I'm going to leave that one for you. Tell whether the quadrilateral is a parallelogram. Once again, that's up to you. Tell whether the quadrilateral is a parallelogram. I think we've actually seen a question very similar to this already, but that's for you to decide. And we come to our next theorem. If the diagonals of a quadrilateral bisect each other, then the quadrilateral is a parallelogram. Okay? Okay. So all that is really saying. I'm sorry, I'm just checking one thing real quick. Okay. So all that we are saying here is that if the diagonals bisect each other, the quadrilateral is a parallelogram. So this is kind of the opposite of what we had said last time. We said that in a parallelogram, the diagonals bisect each other, but it turns out that the other way is true as well. If the diagonals of a quadrilateral bisect each other, then you must have a parallelogram. Okay? So that is to say that if this and this are equal to each other, because it is bisected by this diagonal here, and if this angle, this side here and this segment here are equal to each other because this one bisects them, then you know the diagonals bisect each other, and so you must have a parallelogram. So let's fill in our missing information here. In quadrilateral ABCD, AE is congruent to EC, and DE is congruent to EB. Therefore, ABCD is a parallelogram. Theorem 8.9. Notice I didn't go quite in order there, but I am using two different books, so I wanted to keep the theorems equal. I wanted to keep the theorems named the way that you are used to seeing them named, so I moved a few things around. Theorem 8.9 says that if one pair of sides of a quadrilateral is parallel and congruent, then the quadrilateral is a parallelogram. So now we don't need to talk about two sides anymore. If I know something special about one pair of sides, opposite sides, namely that it is both parallel and congruent, then automatically I have a quadrilateral. Again, not a really complicated concept to grasp. So in quadrilateral ABCD, I have that AD is congruent to BC, and AD is parallel to BC. So therefore, ABCD is a parallelogram. Moving on. Tell whether the quadrilateral is a parallelogram. I want you to use what we have already, we have just learned, and I want you to think about, is this covered by a theorem that we've learned? Or maybe can I find a counterexample, something that would have opposite sides that are parallel and a different set, so opposite sides that are parallel and a different set of opposite sides that are congruent, and whether I can then prove that it is a parallelogram, or find a counterexample where that's still true, but I clearly don't have a parallelogram. Okay, and I'll leave the rest of that for you. And I will leave this one for you as well. As with that one, as with that one, and we will do this example together. Three interior angles of a quadrilateral measure 67, 67, and 113. Is this enough information to tell whether the quadrilateral is a parallelogram? Well, before I reveal the answer, let's actually look at two possibilities. One possibility is that 67 and 67 are like this. And then I have my 113 here. And because you know a quadrilateral has the sum of 360 degrees for its interior angles, That leaves 113 over here as well. And you know you do have a parallelogram because opposite angles are congruent. However, there's another possibility here. I could have something like this. I could have 113, okay? Then I could have 67. Then I could have 67 again. Let's see, could I draw that quite correctly? Yeah, that looks about right. And then you'd connect them like that. 1, 2, 3. Too many sides, actually. Let's see, how would we do this? The point is, really, that I hate my computer. The point is that you don't know what order these are actually done in. Okay? That's the picture I was going for. This trapezoid here. If we had 67 here, 67 here, 113 here, and then 113 over here, that totally works, but we have a trapezoid instead of a parallelogram. So with these two options, this one and that one, there's not enough information to actually say that you know it's a parallelogram. It depends on what the order of the angles is. So that's a good thing to keep in mind. And we are going to finish up by reviewing these next two slides. Fill in the blank. In a parallelogram, the opposite sides are what? Okay? The opposite sides are congruent and parallel. The opposite angles are congruent. The consecutive angles are supplementary. And the diagonals bisect each other. Let's see if I did that right before we do an example. Parallel and congruent. Congruent. Consecutive angles are supplementary and bisect. Yay, I didn't make any mistakes. Okay, so let's think about that real quick. Got a parallelogram. It says that opposite sides are congruent and parallel. Okay, so we know that this and this. Change colors. I know that this and this must be congruent. This and this must be congruent. That's parallel. Those are parallel. Okay, congruent and parallel. I know that my opposite angles must be congruent to each other. So if that's that, then I know that is also the same. And then this would be the same as this. Finally, we know that if I have x, y, x, and y here, I know that any consecutive angles must be supplementary, so x plus y has to equal 180. And I know that my diagonals bisect each other. I'm going to draw another one so it doesn't get quite so crazy. I know that if I have two diagonals here, that this and this must be equal to each other, and this must be equal to each other. Okay? Just summing up what we know about parallelograms. Okay? To prove a quadrilateral is a parallelogram, both pairs of opposite sides of a quadrilateral must be congruent to each other. Both pairs of opposite angles of a quadrilateral must be congruent. Okay? Each of these statements is enough to prove it. And an angle of the quadrilateral must be something to its consecutive angles. Okay? So we know that that's supplementary. An angle of the quadrilateral must be supplementary to its consecutive angles. The diagonals of the quadrilateral bisect each other. Or one pair of opposite sides of a quadrilateral are blank and blank. As we just talked about, parallel and congruent. Any of these any of these statements here, and I will number them so we can see them. Both pairs are opposite. Both pairs of opposite sides are congruent, or both pairs of opposite angles are congruent, or an angle is supplementary to its consecutive angles, that's 3, or the diagonals bisect each other, or one pair of opposite sides of a quadrilateral are parallel and congruent. Any of these 5 conditions, if they are met, you know you have a parallelogram. Okay? And there's no other way for you to have a parallelogram. You must be able to show one of these or more, and you can say that you are in fact dealing with a parallelogram. And I believe we are done with this video. That one's for you. And we are done.